Hi everyone, my name is Mike Reinhardt. I'm from Obsidian Systems, and today I'm going to give a demonstration of our Nervos ledger application. So we received a grant from Nervos to develop this application. We've reached the conclusion of our first grant, and it felt like a great time to update the community on the progress that we've made. So I'm going to walk you through how to use the application in a DevNet and do all the most common operations. I'm going to show you how to have CKB CLI detect your ledger device, access an account or an address from that device, and then do a transfer, and then also all the DAO operations, deposit, prepare, and withdraw. Now you can do all these instructions yourself if you like. We have all the instructions in our README in our ledger repository, which can be found at github.com/obsidiansystems/ledger-app-nervos. And so here I'm going to use two terminals to do this demonstration. You'll see that I'm in our ledger repository for each, and in our ledger repository we pull in all the elements that we need to do this full demonstration and walkthrough, or to do our testing. And you'll see in this terminal I have accessed CKB CLI, and I have just run account list here. And so if I run account list, what you're going to see is the functionality you expect, which you currently find in CKB CLI, but it's also telling me about a ledger hardware wallet that it has attached, and it has a ledger ID associated with that. So I'm in the Nervos application right now on my ledger device. It just says use wallet to view accounts, which is what we've just done with the command line. In this other terminal here, I have set up a DevNet. Now this is very, very similar to your standard DevNet instructions that you can find in other Nervos documentation. We've pulled it here into the repository. And a DevNet, if you're not familiar with it, is just going to run a very small network for testing purposes. So I have one node and one miner in this network. And the miner is actually my ledger account. So as blocks are produced, and they're going to get produced very quickly in this DevNet, that's going to create new cells associated with my ledger address. And then I'm going to be able to spend what I earn for being the miner on the network. So I follow the instructions that are available, and I've initialized my DevNet. I've gone into the 3 files that you create when you initialize the DevNet, and I've set some parameters so that this is a nice, quick DevNet. And if you want to learn more about that part, this is documented in our documentation. But I'm going to skip right ahead into the actual ledger parts itself. So what I've done here is I've run CKB run and the ampersand symbol, which is going to start the node, and it's going to run it in the background. I've also run CKB miner, and what we see is that our miner has gotten started. Now when I press enter, the network is going to start producing blocks. And I can pause those blocks at any time. So I'll keep the node running, but the miner will be paused. And then I can just restart the network whenever I want. So I'm not going to leave this DevNet running the entire time. I'm only going to run it when I have an operation that I want to see included in the chain, or when I need a given period of time to pass, such as if I'm looking to withdraw from the Nervos DAO. But for now, I don't have anything running at all. So let's just get that going. All right. So what we just saw is we let this DevNet run for a while, and we produced 39 blocks in just a couple of seconds. So let's check that out. I'm going to go back to my other terminal here. Now, I got the ID of my ledger device, and this is an actual identifier of the device itself. This isn't anything to do with my accounts, but it is just how we would then use other operations to get one of my accounts. And let's go ahead and do that right now with extended address. So what I've put in here is I have account extended address, and I'm going to pass a derivation path. So I have a BIP44 derivation path for the account that I'd like to access on the device. And this account ID, this is my ledger's ID. So with that, I'm going to go ahead and submit this operation. And what you'll see on the device is it asks to provide public key. It confirms the derivation path that we've input. And now it's showing our testnet address. So there is a configuration on the device for whether you'd like to show your mainnet or your testnet address. I set that up before the demo, but it's easy to access from the device's settings. I'm going to confirm, and here we see on the client, now we see both that mainnet and testnet address that I derived. We have my lock arg and also my lock hash. So now I have a testnet address I can use. Now, this is the miner, and we did run a few blocks before. So let's just first check our capacity and see what we have. So already we see I have about 58 million CKB, of which about 800,000 of that is not yet mature. And if I want to just get my cells as well, we'll see I have a total count of 29 cells. A little less than the 39 that we have on the network. So now that we have our account and we have a balance on this account, let's go ahead and do a transfer. So I'm going to pull an operation I've constructed here for doing a transfer from my ledger address. I'm going to paste that in here. So what we see, we have our from account, right? That from account corresponds to what we have on our ledger device. We have a to address here. That's another address I own. That's my software key. I'm going to do a capacity of 100, so I'm going to transfer 100. I have a small fee on here, and I'm going to go ahead and run this operation to do this transfer. Now, the client as is doesn't really know anything about this ledger device. Nothing is stored. All it can tell is that ledger ID when I derive it. So as this operation is constructed, I don't actually have my address in that from account. So when I do this transfer operation, you're going to see this provide public key command again. That's the client learning what my actual address is from the device while I'm constructing it. And that's going to happen again to determine my change address. And we're going to see this for any time we do an operation. So we're going to see this during this transfer, and we're going to see this during DAO operations. Once it has both of those, it's going to go into the transaction. So here we see confirm transaction, the capacity, the fee, and then also the destination of this operation. I'm going to confirm this information on the device like you should always do when you're using your Ledger hardware wallet. This is where you get a lot of your security from. And Ledger hardware wallet is actually verifying the contents of your operation on the device. I encourage everyone to do it every time. Now that I've signed that transaction, we see the hash here. So this operation's been signed. I produced this transaction's hash, but it's not in the blockchain yet. Remember, my miner is still paused. So I'm going to go ahead and run FG, which is my command to restart my miner, and I'm going to very quickly pause the network. So in that brief amount of time, let's see where our network head is. We're going to do RPC get tip block number. We see it's at 45. All right, total nonces found is 45. All right. This operation should have been included. How can we test that? Well, let's take a look at this operation. I'm going to do RPC for getting the transaction. And I'm going to provide this transaction hash. And here we see it. The status of this has been committed. Here's the block hash that the operation can be found in. Our outputs from this operation, you see the first cell has the capacity of 100. This went to the address that was the destination. And then I have my change. So this is the capacity that was part of the cell that was the input to this operation, which is not going to the destination. And that goes to my change address. And that's how you do a transaction. Now that we've got that done, why don't we take a look at DAO operations? So I'm going to get started by doing a DAO deposit. And so I'm going to copy my operation that I have here. And here we see DAO deposit, the capacity that I like to deposit. Let's do something different. Let's do, say, 99,999. From is going to go from my ledger ID. We have a transaction, and then this is the path. So this is the ID of my ledger device and the derivation path I'd like to use. First, provide public key. Second, provide public key. And now we're going to see to confirm DAO deposit. We're going to see the capacity and the fee. I'm going to go ahead and confirm that DAO deposit. And now we see the operation hash show up on the client. Again, that doesn't mean it's in the blockchain yet. We're going to very quickly run our blockchain. Here we see we went 5 cells in that brief period that we ran it. But now I want to confirm that I actually have cells deposited in the Nervos DAO, or a cell deposited in the Nervos DAO. So I'm going to do a check with my address. And here we see 99,999. Here's our deposited cell. Next up would be to prepare the cell for withdrawal. So before I do that, I'm going to just run this sandbox miner a little bit more, get further down the network, and now let's do our prepare operation. So here, very similar to doing the deposit, I have to provide a bit more information about this out point. So I'll take this transaction hash, and we have our from account. I'm sorry, this is the ledger ID. We have our path that we want to use. This is the same derivation path we've been using because we're using the same address. I'm going to go ahead and run this DAO prepare. So here we have that first provide public key operation. I'll accept that. By the way, these provide public key operations that we're seeing, these are going to go away under our second grant application. Part of what we're doing in our second grant application is adding the support directly into upstream CKB CLI, but we're also improving it in a few ways. So first, I'm just going to accept this, and now I want to see this DAO prepare. See, confirm DAO prepare, the amount, our fee. All right, excellent. Let's confirm that operation. So what we're planning on doing in our second grant application is storing more information about your account in the client. So that the client won't need to ask the ledger device every time you're doing an operation, hey, what account is this that you're trying to use? It'll be able to determine that and the change address on itself. So you're going to have a much better user experience. What we're also doing as a part of that second grant application is a lot of changes that'll make using these types of hardware wallets very secure, and it will also allow support for any other hardware wallet with on-device verification. Back to this prepare. So now I've got my transaction hash. This prepare was successful. Let's do a quick run on the chain. All right. Tip block number is much higher because I let it run before. But now we should see this operation is included. So I'm going to query for our prepared cells. And there it is. There's the same cell, 99,999 is its capacity. This is great. Next up is to actually do the withdrawal. Let's let this DevNet run a little bit more again. Excellent. And here is our DAO withdrawal operation. Same, very similar to before. We're going to pass it the ledger ID and the derivation path we're going to use. I'll provide this transaction hash for my out point. This operation is ready to go. Provide public key. Here we have confirmed DAO withdrawal. Our amount, our fee. This is ready to go. You may have noticed that this is also confirming the return that you're going to get from being deposited. It's a nice additional feature. This transaction is now signed. Let's take a look at it. So if my withdrawal was successful, I shouldn't have any more prepared cells because my prepared cells were just withdrawn. See what happened there? I signed this operation, but I never ran the DevNet. So when I queried for prepared cells, that cell is still prepared. It's not withdrawn yet. Let's change that. I'll run the DevNet for just a couple blocks. And now when I query for prepared cells, it's not there anymore. So that is all the core functionality that we set out to achieve in this first grant. We've been able to detect the ledger device, retrieve addresses from the ledger device, do transactions, and then also do all of our DAO operations. Now, I want to call out an interesting improvement that we've made to the application as we've moved forward with its development. These ledger devices are pretty constrained in terms of memory and resources, and that's not a bad thing, but it does put some limitations on the device and what we're able to do with it. When we were first doing transactions and we were sending all the information about the transaction to the device at once, we saw that we could really only get 4 input cells to be a part of our operation. That's okay, but if you're a miner, like my ledger address is right here, you may find yourself with many, many more cells than that. And everyday token holders, who have CKB may also find themselves with many more than that they want to include in an operation. We definitely want to be able to support as many use cases as we can. So we've made some adjustments to the application so it can accept a virtually unbounded number of inputs into an operation. And that's what I'm going to show you here now. So I've gotten the capacity of our ledger address. And here I've got about 510 million CKB. Of that, I have about 8 million is still immature. And let's just see how many cells I have. All right, I have 255 cells total. Let's use a lot of those in putting together a transaction. In fact, let's use just about all of them. So I'm going to go and I'm lazy. I'm not going to scroll up. I'm going to get my capacity again with another command. And I'm going to determine basically what is the maximum amount of CKB that I can transfer, the maximum amount of mature CKB. Oops. All right. So about 502 million or so. Easy math. So let's grab a transfer operation. I'm going to take that same one I had prepared, but let's make some alterations to it. Okay. Now, for our transaction fee, from experience, I know this small fee isn't probably going to quite do it. So let's just set it to 111. All right, and our capacity, we want to do way more than 100. Let's just do 500 million. This is going to take a lot of my cells. This operation looks ready to go. Let's submit it. And I'm doing provide public key number 1, provide public key number 2. And what you're going to see here is a brief pause. Now, this is going to depend on the size of the operation you're streaming to the device, as in the number of input cells that you're streaming to the device. So the more and more input cells, the longer it's going to take this information to stream. But in this case, we have approximately 200 or so. And here's the confirmation on the device. I'm seeing confirmed transaction, the amount, there's my fee, and my destination address as well. So that one probably took us about 10 seconds or so to get all the information. But we have that verifiable prompt that we're looking for. This is where the security comes from. I'm going to confirm this operation for 500 million CKB. There is our operation hash. So remember, I had 255 cells at the start of this operation. I've now signed it. Let's get it included into the chain. And now when I run get capacity, all right, my capacity is much lower. Let's do get live cells, 16. Now in there, some of these cells, so see the last time I restarted, we got a few additional cells just from this chain running when I included that operation in the chain. But we went from 255 then to 16 cells now. So we're signing about 240 cells in that operation that we just put together. This will be a great feature for any miners or anyone else who has lots of input cells that are going to go into their operation. So that concludes the majority of this demonstration. Like I said before, I really encourage you to try this out yourself. If you have feedback on this video or in trying this yourself, we're more than happy to hear it and make improvements to the application. We're looking forward to getting this into the hands of everyone in the Nervos community. And you can reach us through our GitLab, or I'm sorry, our GitHub account by leaving an issue if you'd like to learn any more. You can also find us in the Nervos Telegram groups or reply to our grant application in Nervos Talk. Thanks again, everyone, for watching. Look forward to producing more of these in the near future.